So how many of you guys have heard of blockchain technology? Raise your hand. Sounds like pretty much everybody, and if you haven't already, I'm sure you're gonna be hearing about it sooner or later. If you look at some of the headlines that you see in Wall Street Journal, Bloomberg, even USA Today, there's amazing stuff happening in this space. So you have some of these states actually passing legislation saying that things like stocks could be put on blockchain, that smart contracts are legal, things like that. IBM's been very active in working with a lot of different industries, trying to help them discover how they can use blockchain. Microsoft, some other countries are actually looking at using blockchain for national identification systems. It's the value transfer revolution, right? So previously, we were able to transfer information on the internet, but there was no way for us to transfer value on the internet. I can send you a file, but I also keep a copy of the file. But if I sent you some money over the internet, I shouldn't be able to keep a copy of that money, right? So how can we do that? Well, Bitcoin kind of showed us that, how to do that. And after that, it actually took a little while before people actually realized that the technology behind Bitcoin was really useful for a lot of other things, right? So it wasn't even until 2013, if you go to Google Trends and you type blockchain and you look at the graph of the trend for blockchain, it's you don't even see that starting to pick up until 2013. And Bitcoin was there. It mentioned blockchain in 2009. But now that people are catching on to what you can do with that technology, it's really taken off. So it's going to impact a lot of sectors. The financial sector for sure is, it's like the low-hanging fruit. But it's going to impact a lot of other sectors. And the way I look at it, it's in a way also like how the database revolution, which started in the 1970s, in a way still happening now. There's new types of databases coming out, right? Like NoSQL was just, maybe a decade or two ago that we started looking at that. And there's even newer technologies, graph databases and other types of databases. So I also think that with blockchain technology, it's going to be something that plays out over many decades. It's not something that's just going to happen in a year or two and we're done with this. It's not like that. The technology is going to be evolving. Applications are going to be evolving on top of that technology. There's going to be constant change. There's going to be a lot of new companies that get created from this. And so Shardus is going to be one of those companies that's going to be a player in this space. So basically, what is Shardus? So Shardus is software that you can use to easily create your own blockchain. I mean, I'm using the word blockchain here because people just keep using that word a lot. People understand it more. But we actually like to use the word distributed ledger, which is not as commonly used, but it's pretty much means the same thing. But distributed ledger, I think, actually describes it better than blockchain. But anyway, so what Shardus is doing is we're trying to build the software with which you can create a blockchain or distributed ledger, make it very easy for developers to use, build it so that from the early design decisions, it has the ability to scale, and not just scale to say 1,000 transactions per second, and then we have to go find another solution. Or after 10,000 transactions per second, we've hit our limit. We're making it so that it can scale unlimited by just adding more nodes. And we're also trying to keep a focus on making sure that it's energy efficient, because in the long run, I think making systems that are energy efficient matters a lot. and also, making our system so that it's very highly decentralized by allowing very simple off-the-shelf nodes to be able to run the software. And basically our business model is that the software will be licensed, right? So the current issues with blockchain technologies, if you're familiar with Bitcoin, Ethereum, a lot of the first generation blockchains that are out there, they just don't scale at all. Like Bitcoin does about 2 to 4 transactions per second. Ethereum's like 20 transactions per second. There's second generation chains coming out that are now getting into the thousands of transactions per second. But very few projects are trying to build it so that it's unlimited scaling. Also, the decentralization aspect of it, like especially when you have a public blockchain, it's very important that the people running those nodes are not colluding, because what this blockchain and distributed ledgers are doing is allowing you to let them take on the trust issue rather than some third party. But if you can't trust the blockchain because it's all controlled by one party, then you've lost the decentralization aspect. So especially in public blockchains, it's very important that there's a lot of entities that are unrelated who are running the blockchain. And so, like with Bitcoin, now you've like only about 4 or 5 big miners running that system. So you're losing some of that decentralization that Bitcoin had originally. Also, it's not very energy efficient. The way that things are going with proof of work, it just keeps sucking up more and more energy. Bitcoin has passed up the energy consumption of several small countries like Denmark and Switzerland. So I don't know how long we can sustain this, but part of it is that you use that energy to capture the value in Bitcoin. So the value of Bitcoin partially comes from somebody having invested in creating those Bitcoins. But we'll see how it goes, because in the long run, I think systems that are more energy efficient will win out. So the goals of Shardus is to achieve what's called linear scalability. Basically, it means that as you add more nodes to the network, you should be able to get more transactions per second. You should be able to handle more data storage. Also, we want to maximize decentralization. Like I said, you need to have a lot of unrelated parties contributing to the network in order to maintain that decentralization. And also maximizing efficiency. Having systems that are more efficient, I think, will win out in the long run. And so, what are we doing to try to achieve this? So our key technology that we're building into Shardus is called sharding. And so sharding basically says that you take all the nodes in your network, and the network can automatically divide itself into different groups called shards. And as transactions come into the network, different transactions are processed by different shards. Now there's two basic types of sharding. One is transactional sharding, one is state sharding. And some projects are only doing transactional sharding. With Shardus, we're trying to do both transactional and state sharding, which is actually a lot harder. But it actually lets you achieve linear scaling. And also the other thing that we're doing is we're blockless, in the sense that we don't put all the transactions into one block and then do consensus on that block of transactions. We do consensus per transaction. So what this does is it allows you to be able to process transactions almost independently, rather than kind of grouping them together. It's kind of like, if it takes you the cost of doing your consensus is expensive, then it does make sense to put a lot of transactions into a block and do consensus on it altogether. It's kind of like taking a bus versus taking a car, right? If the cost of gas is really high, we would all be taking buses. But it's more convenient if the cost of gas is low to be able to take your own car. So we're trying to set up a model where transactions are processed individually. We're using what's called proof of quorum. It basically is a way of nodes signing off and saying, hey, I voted for this. And if a majority of the nodes can sign off and demonstrate that they voted for something, then the rest of the network has to agree. And that's a lot more efficient than using something like proof of work, where it's based on the majority of the energy dictates what the network has to agree to. And we're building in features like auto-scaling, where the network will automatically allow more nodes to join the network as the transaction throughput goes up. And it also kicks out nodes from the network if we don't really have that much transaction throughput. And so, why would you pay all these miners, like thousands and thousands of miners, to join your network if there's hardly any transactions going through your network? So in those kind of scenarios, it makes sense for your network to shrink itself down, and when traffic picks up, the network should grow. So we're building those kind of things that you see in distributed systems that people build in enterprises. I've worked in enterprises all my life, and built these kind of systems, and being able to scale your back-end systems is very important. And we also have a feature called rate limiting, where if there's more transactions being thrown at the network than what the network can handle, the network will automatically tell you that, hey, resubmit your transaction. I can't process it right now. This is a different design decision than what some of the blockchains are doing, where they'll take every transaction that comes in and just put them into a backlog. And so sometimes if the Bitcoin network is busy or Ethereum is busy, you could submit a transaction, it's not going to go through for a day or two. And then people get impatient, and then they have to figure out how do I cancel that transaction and so forth. So we're building rate limiting, that way you don't get stuck with those kind of problems. So the advantages with Shardus is linear scaling, so it's really transactions per second per node, not just we can hit 10,000 transactions per second. No, it's if you hit that whatever limit, just add more nodes, and you can continue to process more transactions. It has a fast settlement time because every transaction is processed independently. They don't have to be, put together into a block and wait for the block to get consensus upon. The consensus is more efficient. We're trying to design it basically with the unbounded network size. So eventually, you should be able to go to hundreds of thousands of nodes, maybe millions of nodes. And you don't want to have an impact from other applications. That's why there's going to be certain applications that are using a blockchain or distributed ledger where it needs to have its own network. You can't put everything on something like Ethereum. Actually, I feel that there's a lot of decentralized applications being put on Ethereum, which if they actually got really popular, the Ethereum network wouldn't be able to handle it as it is now. And even after it, achieves scaling, there will be other trade-offs in terms of latencies and things like that, where it won't make sense to do that. So certain applications do need their own network, so that they're not impacting other things, and other things are not impacting them. And we're building a system so it's very easy to create with and deploy. So what are the use cases? Essentially we see that in the future, as this blockchain technology plays out, there can be really global scale decentralized networks out there, right, that have billions of daily active users using that same network, and millions of transactions happening on this network. So we're trying to think to that level and design to that. It's going to take a while for us to get there, but we're working towards that. And some of the things that could require a global scale network like that is if we had a global currency, right? Imagine if everybody in the world was using the same currency, and the currency was stable, and it's something that people could transfer across the world. Something like that would have billions of daily active users. It would have millions of transactions flowing through that network. Also, right now we really don't have any kind of identity system. I mean, every country has to deal with the problem of issuing identities, and every country has its own identity system. Well, what if in the future we have a global identity system, and each of those countries just become a consumer of that identity system rather than having to maintain and manage their own identity system? So we could go to some, global identity network in the future. And also communications is something that, we could potentially see global decentralized communication networks, right? Right now we use things like WhatsApp and Telegram and things like that, but all of those are going through companies like centralized. It would be awesome if we had decentralized systems that could do these things. And then social networks, right? Like so many people are on social networks right now, and then now they're starting to get fed up with the company behind the social network, having so much power and dictating. I mean, in the long run, we really should have decentralized social networks. Country coins, a lot of countries are asking their central banks to look at how can we put this country coin on a blockchain or distributed ledger. One of the biggest problems for countries is trying to fight counterfeit, right? When they have like physical cash, that money can very easily be counterfeited, but if you have it on a blockchain, it duplicates cash, but very hard to counterfeit. And there's going to be lots of enterprise applications, and those are going to be like very high throughput. So we have a team of very experienced veteran guys who have worked in the industry for many decades. Myself, I've worked at Yahoo, NASA, Zynga, consulted for a lot of startups, and finally working on something that I really think is going to have a big impact on the future direction of a lot of technologies. I have Andrew with me, who's worked with me at Zynga. Really awesome. He's worked in the game space a lot. He's one of the developers on Halo Wars. He's helped build Castleville and so forth. And Samir, he's worked at Office Max, Chevron, Yahoo, Cisco. He's helped, I think he was involved with Yahoo's front page. So these guys have worked with systems that have handled like millions of daily active users. And we also have like younger guys, like Derek, Kyle, and Amir, that are also part of the team. Amira, our youngest one. So, we have a lot of awesome talent on the Shardus team. And the key thing is that we're focused on execution. We have a roadmap. We're transparent about where we're going, and we, present ourselves. I don't know if you ever participated in these ICOs and things that are going on. There's a lot of projects creating hype, and right now it's very hard to tell the difference between which project is just hyped and which is really creating real technology and creating value. I read somewhere where like 80% of the projects that raised money in the ICOs back in like 2017 died because of lack of any development. Like they raised the money, and then if you go to their GitHub site, there's nothing being created. Right? So we're very focused on execution and getting something out. So I'm going to talk a little bit about our token. So I've been advised to say that this is not investment advice. I'm not telling you to invest in Shardus tokens or anything like that. You should do your own research, your own due diligence, and make your own decision. But essentially, so the way that Shardus works and funds itself is that we've created an ERC20 token. It's on the Ethereum network. It's transferable between people. It's there now. The token is not sold by the project. It's only given to people that work directly on the project. So all our developers are basically given token for the contributions that they're making to the project. Now they can do whatever they want with their tokens. They can sell it to friends and families. They can, convert it on exchanges. So one of the things that helps that this model is useful for is that it saves a lot of time and resources in terms of fundraising. If you guys have ever done a startup, you know how hard it is to do fundraising and worry about making sure you have the money while you're also trying to sit there thinking about the technology that you're trying to build. It's a pain in the neck, but we're like one of the first persons that are putting out this kind of model. But I really think that in the future more projects will be taking this approach. And the way we're doing it, I think it helps to better align the incentives, right? So all of us guys are very incentivized to make sure that this project succeeds, right? Like we put our sweat equity into it. We have our tokens. If those tokens, appreciate in value, then that's where we see, a return on our investment in terms of putting in the effort to create this technology. So the token supply. As like I said, as the project gives out tokens while the software is being developed, the token supply is increasing. Right now during the development stage, it's currently at about 14 million Shardus tokens in circulation. We expect that by the time the project finishes, it could be about 40 million tokens in circulation, and that's including like a lot spent on marketing. And the token price, the project uses a token value of 10 cents per token. And so if you use that, it basically means that by the time we complete the project, we would have like a market cap of $4 million. So, having this kind of technology and valued at $4 million is, a really good proposition in terms of, in comparison to like the market caps of a lot of other projects that have not actually even delivered anything. And then once the project releases, the way things work is that the software licensing is going to cause the token supply to start shrinking, right? So no more new Shardus token will be given out, but as people license the token and consume those Shardus tokens, then the token supply will start to shrink, and as part of that, the value of the tokens will increase. So here's a more detailed explanation of how the software licensing works. So basically, you have the Shardus software, which is then used to create lots of blockchains and decentralized applications, both for enterprises and for public use. For enterprises, they would buy the Shardus token, send them to our Ethereum contract, which burns those tokens and issues you a license token, which is on the blockchain, and you can easily prove that you've purchased a license for the software. For public projects, what we're asking is that those projects, they'll typically have their own coins for their own network. So we ask that they give like 1% of their coins back to the Shardus token holders. So that actually helps the project gain people who are already familiar with blockchain technology, helps them come and use their project, and it helps the Shardus token holders in terms of gaining coins on other networks. So our roadmap, like I said, this is our 5th quarterly update. We've been doing quarterly updates since 2018. Our first one, we showed our consensus algorithm, then we demonstrated our distributed ledger. Now we're focused on demonstrating our sharding. Last quarter, we demonstrated sharding in a static network. This quarter, we're going to be demonstrating sharding happening in a dynamic network, meaning that nodes can now start to join the network, leave the network, and the network maintains the sharding. And next quarter, we're going to actually start using the Shardus software to start building what we call the Liberdis network. So Liberdis is basically a payment network and coin. And really, it's going to help us make sure that the technology that we're building with Shardus is something that can get deployed and will scale. So that's what we're going to be building, and that's going to take us a few quarters to the point where we have Liberdis ready for a mainnet launch. So our status, basically, this quarter we've been focused on what we call the global server. And the distinction between the global server and enterprise server is that the enterprise server doesn't do sharding. The global server manages the shards. So we, focused on getting the initial nodes to join a network that's sharded, and then as nodes, also more nodes join or leave the network, some of the nodes will have to resynchronize their shards and so forth. So it sounds simple, but when you really get into that, there's a lot of technical complexities in handling that, which is why not a lot of projects are really working on doing sharding, and especially state sharding. And already we've, on last quarter we demonstrated, transaction routing, the sharding of the states and transactions, cross-shard communication, and so forth. And so we have to continue to manage that while the network is dynamic. There's a couple of things that we wanted to get, but we weren't able to get completed this quarter, which is what we refer to as partition repair, which is a scenario that you would end up in if one of your nodes temporarily lost a network connection and missed transactions and so forth. So the nodes need to go back in and be able to repair the partitions that they're holding. Also, the archive server, which offloads all of these transactions that are coming into the network and sends them off to an archive server, so that it makes it such that the nodes themselves that are doing the consensus can focus on only holding the state that's needed for the consensus and not have to carry all this extra load of also keeping all the transaction history, right? That can get offloaded to archive servers. And also, we're creating partnerships. So Dan from Temple Group is here with us, and they've reached out to us, and they have some ideas in mind of how to use, Shardus, and they're evaluating it. There's another, couple of projects that have also contacted us, which are looking at evaluating Shardus for the applications they have in mind. And this is just getting started. I think as this technology progresses and more people learn about Shardus and what we can do, we're actually going to start having to partner with blockchain consulting companies so that they can handle the end clients, and then we can provide them support in terms of making sure the Shardus software meets their needs. One interesting project that reached out to us, so the African countries are getting together to create an African Union, and somebody that's working on that project, the African Union project, reached out to us and said, we were thinking about using a cryptocurrency as the currency for the African Union, and we weren't able to find any project that we think that could continue to scale indefinitely. And we see that you guys are trying to focus on like unlimited scaling. So they reached out to us, and they're actually hired one of our remote developers to help them actually build a prototype. And also, we do some small presentations here and there locally. This past quarter, we presented a little bit at the UTD Blockchain Club. Also, we did a presentation at IEEE's, I forgot what exactly that was called, IEEE Technology Day or something like that, but I presented about blockchain applications there and mentioned what Shardus is doing. The other thing that we've done, and actually we started this the quarter before, is we're building a decentralized exchange on the Ethereum network. It's called Uniswap DEX. It basically allows you to convert any ERC20 token on the Ethereum network between that token and Ethereum, and also it's easy to convert from any token to any other token. And it uses some smart contracts that were originally funded by the Ethereum Foundation. And we're basically putting together a interface to those smart contracts. And we're trying to create a more friendly interface. And also, so as people use that, they learn about Shardus and, hey, look, Shardus built this a project for free. And there was also another project called Bancor that raised like $150 million to pretty much do the same thing. We used like one resource over like 4 months and we built the same thing. So plan going forward. So this quarter, as I said, we're going to be focusing on LibreDesk. We're building out the website. If you go to libredesk.com right now, it's already up there. We have the white paper up, but we're still open to feedback from the community, and still in the kind of the design phase of what LibreDesk should be like, and where we want to go with that. And this quarter, we're going to be essentially using the Shardus software and building the LibreDesk application on it. And by the end of the quarter, we hope to have something that people can start using, and in terms of like creating a test net and trying it out. On the global server side, which is actually the Shardus software that does the sharding, we're going to focus on bringing up the archive server so that it can take the load off of the consensus servers. We're going to focus on doing the data repair to make the system more robust, and just generally making our code more robust so that it can handle like anything that's thrown at it. So now we're going to start doing a quick demonstration of the linear scaling. So basically, you'll be able to watch in real time as the network grows and the transactions per second increases. So I'm going to switch over. So the first step of that is we're going to start up 20 nodes, and then after that, we're going to actually let you use your browser on your mobile phone to go to those sites and try to submit transactions in this network. But let me switch over right now to the all right, great. So one of the things, if you've come to our presentations in the past, you've probably seen us do similar demonstrations like this. So all of these green dots there are different nodes, and those nodes are, yeah, okay, cool. So usually what we do is we launch these nodes on AWS, but it takes about 3 to 4 minutes from the time we start up the node until it comes up to speed and even shows up on this graph. And because we're going to be starting up nodes again and again a few times, so it would have taken us like 15 minutes of wait time just to wait for the nodes to come up. So what we've done is we've set up the same demonstration on a powerful single node. So it has like 48 processors, a gigabyte of RAM. So we'll be able to like spin up the nodes like almost instantly. And I think Amir's got 10 nodes going up there already. And this table up here kind of shows you how many nodes are active and how many nodes the network wants. And then here we'll see like how many transactions were processed. Now these nodes are actually, every so often you'll see like a transaction fly through the network. These nodes are putting out a transaction that says, hey, I've been participating in the network for the last 10 minutes or whatever, give me some tokens, right? So that's their way of earning tokens on the network. So you'll see like these nodes put out a transaction, and then that transaction propagates through the network, and that's how the nodes receive their reward. So we're ready to go?
Yeah, so awesome. So as you can see, we have 10 nodes started up. We also have a application running on this network. It's a chat application. So something like this. If you go to kyle.shardus.com on your mobile device, you'll be able to participate. Basically, it's a very simple chat application that we built on top of the Shardus platform. And it was a way for us to optimize like the whole process of application building and how to make that better. So we have this running on this network that you see here. These are the backend nodes that provide the APIs for this application to use. So you can go ahead and create an account, add in the username, hit submit, and this should show a transaction go to this network. There we go, successfully created an account. You may have missed the transaction, but the account got created. And this should take you to like a balances page where if you hit this button here, you can send messages to anyone else who's created an account.
But they should probably claim some tokens first.
Oh yeah. So
what we did,
yeah.
Let me just take a moment here to explain. So what we did was we made it so that like anytime you send a message to somebody, you have to pay a little bit to the person that you're sending the message to. Or actually, I think we have it so that it gets burned up right now, right? Okay,
Yeah.
so it just it charges you a toll whenever you send a message. So you're not going to get spammed on this network. So you won't be able to send a message to each other, but what you can do is click claim tokens, and if you go to that, you'll be able to claim some tokens to get started. All right, Amir, go ahead.
All right, so as you guys are using this application, we're going to spam some transactions into it to show that the network is able to handle this type of load. The first thing we're going to do is spam transactions at 100 transactions per second. And we'll watch the network monitor here and see these numbers and see how it's able to handle that. So let's get started.
Yeah, so if you watch these numbers over here as the transactions start coming in, you'll see these numbers starting to go up. We're hitting the right network.
Yeah.
Because there's two servers that we have.
Oh, that's what happens. Computer lost connection.
Okay.
That's what happens. Yeah, UTD Wi-Fi.
We're a telecommunications school, don't worry about it. I was able to send them in 4 tokens. He just received for free.
Oh, okay, cool. Awesome.
If somebody wants to send me tokens, my ID is submitted.
Alright, let's do this.
And I think we're also like live streaming the event too, so there's a little bit of bandwidth load on the network. So.
Alright. Secure.
Can I ask you a question while you're waiting?
Sure, yeah.
You mentioned that you pay or you compensate your developers through the token.
Yes.
Is that subject to withholding and FICA SUTA and all that stuff then? And if so, how do you incorporate that?
Well, I mean, that's up to the developers on how they want to report it. Like some of them report it as income, some of them report it as like mining. You know, so in a way, these tokens don't exist until somebody does the work to bring them into existence, right? So in a way, it's a lot like mining, where the Bitcoins don't exist until somebody spends the energy to create them. So it's really up to how they report it.
All right, so now that we have internet connection and we're able to see what's going on, you'll see like small like dots coming in. That's people sending messages like right here in the audience into this network. And so, as you can see, we have total process transactions up here. It's at 1,400 and something. That's because we just spammed the network, and we weren't able to see it because we didn't have connection, but those transactions went through and they were recorded. So the next thing we're going to do is spam it at 200 transactions per second while you guys are using it, and we'll see how those numbers get fed.
Now, it's possible that some of the transactions could start getting rejected now because the network starts getting overloaded.
How many shards are
So there's 5 nodes per shard. So with 10 nodes in the network, there's 2 shards.
So we've started the spamming, as you can see.
Yeah, so you have transactions are getting processed, but also there were some transactions that got lost. You know, you might want to hit the reset the report just so that we clear out this max TPS, because I think that number got
Affected by the,
So now we're gonna add more nodes to the network, and then also run that 200 TPS through it again. And this time we should see like rejected transactions, because now the network is able to handle that load. And also the average transactions per second should go up. So what you see here are more nodes coming in. So at first the nodes will be sitting outside the network, and they're submitting transactions to the network to say, I'd like to join the network. And then the network approves the node to join. And now once these nodes join, you see them in the yellow state. They're part of the network, but they're yellow because their state is not synchronized with the network yet. So these nodes are actually like exchanging a lot of data with the other nodes, but we're not showing all those transactions happening. But right now, these yellow nodes are catching up to what the green nodes have and getting synchronized with the network. Oh, you just saw that one change color. So we should see them switch from being yellow to green as they synchronize with the rest of the network.
Another thing to note is the dots that you see on the green nodes, those are representative of the internal state of the node. So once these yellow guys become green, those dots should all be the same color. That means they've gotten the correct state and they're good to go.
And every so often you'll see like these top 2 dots change color. That's showing that some state inside that node changed.
Oh yeah.
And this green dot at the bottom shows like the overall state of those nodes. So we should see that kind of remain at green all the time unless the nodes get out of sync, then it'll be turned into like red. So far, yeah, the nodes are still working on trying to synchronize with the rest of the network. And keep in mind, the network is not sharded, so some nodes are holding some data, and other nodes are holding other data. And so nodes will tend to talk to nodes that are near them and synchronize with the nodes that are nearby. Okay, so we have like more nodes that got synchronized, and there's still a few more nodes waiting to completely get synchronized here. And I think they're all synced now. I think you should.
All good.
All right. Okay. So we can spanning.
Yeah, so now we're going to span the network with 200 transactions per second again. Go ahead and plug it in. Now this time, keep an eye on the TPS numbers, and rejected should not go up. The network should be able to handle it. Whereas before, when we had only the 10 nodes, the network was starting to reject some of the transactions.
Okay, let's do it.
So this is 200 transactions per second. Oh, you're getting some rejected, dude.
It works.
Yeah. That always happens. But yeah, so we got a max TPS of 139. Some transactions did get rejected. I'm not sure what happened there. Maybe we need to add more nodes.
Yeah. Let's add another 20 nodes.
So we're gonna add.
How many, what do you expect the size of a shard to be? Is there like a size that you will target at 20 or?
So that actually is dependent on the person who's developing the application.
What about
using
the
Shardus?
public network?
On the what?
On the public network.
Yeah, on a public network, you probably want like about at least 100 nodes or so per shard, right? Like in a more enterprise setting, you could probably, 5 nodes in a shard is probably okay because those are like federated nodes that you can trust. But it's really up to the application to decide how many nodes per shard. So Shardus is not going to dictate that for you and say like you need to have this many nodes per shard. It's really up to the application.
Is it up to the application even on public network?
Yeah, so like if you were designing, say like your own coin and you're going to launch a network with it, you would determine what you want in terms of nodes per shard.
Are you, did I hear correctly that you're actually also going to have?
Yeah, so Liberdis.
Yeah, Liberdis.
Right, so that's the first application that we're going to be building using Shardus is a payment and coin network called Liberdis.
So that coin will be applicable across all shards.
Yeah. I mean that's its own network, right? Yeah, it's almost like like Bitcoin is its own network and it has a coin.
So then, so you expect like 100 nodes per shard in the Liberdis network?
Yeah, so when we launch the network, Shardus will contribute with some of the nodes, but then people will be able to download the node software and run their own node as well and join the network. So yeah, I mean typically public networks, the popular ones start getting into like tens of thousands of nodes. I think like Bitcoin and Ethereum have like 10,000 nodes in the network.
So you're sharing the state within a shard. So will you then have to handle transactions across shards?
Oh yeah, absolutely. So like different accounts will land in different shards. And if I do a transfer of a coin from my account to your account, and my account is in one shard and your account is in another shard, there needs to be this cross-shard consensus and cross-shard communication that happens. And we actually already tackled that problem last quarter. And now we're tackling the problem of maintaining those shards while more nodes are, joining the network and exiting the network. So
doesn't the TPS just get killed when you go across shards? Or?
Yeah. I mean, TPS does slow down when you have like multiple shards being involved, for sure. And so, I mean, that's why, like, you know, with these nodes, you're not seeing like 1,000 transactions per second and things like that. You're only seeing like hundreds of transactions per second because there needs to be that cross-shard communication and consensus that has to happen. So, if you don't have a sharded network and every node is holding all the data, you know, the processing on a transaction per second can be a lot faster. But, you know, there's this trade-off, right? So, all right, guys.
Yeah, we're ready.
Oh, wow. Okay, so
Perfect questions while they start up.
added more nodes. So let's go ahead and we're going to do 200 transactions per second into this network.
What's the expectation?
So basically, the injected rate is 200 transactions per second. We should not see any rejected transaction, and hopefully this max TPS hits somewhere close to 200. Yeah, and so it did. There got up to like 200 transactions per second, and the rejected transactions, you know, didn't go up. So that, you know, shows that as you have more nodes in the network, now we actually have like 8 shards. The transactions that are coming in are now getting divided up among 8 different groups of nodes, per se, and then that allows for more parallel processing so that any one node doesn't see as many transactions going through. So now we're gonna like kind of push the network and see how high it can go. I think Amira has a question for me. You have a question?
Yeah.
Oh, what's a network? Good question. See this circle over here with all these nodes talking to each other? That's a network. I know she's going to have follow-on questions. Okay, what's a node? Another good question. See these green dots? Those are nodes. Okay. Yeah.
So we started scanning at 300 TPS.
All right, so we're doing 300 TPS now. And
With how many shards?
it has 8 shards in here.
How many of the transactions are cross-shard?
So we're doing like what are we doing, a coin transfer?
We're doing a coin transfer, and so there's 2 accounts involved in each transaction. Depending on where those 2, the randomly selected accounts are probably going to be in at least 2 shards.
Yeah, so, you know, depending on where those 2 accounts are, you could get a cross-shard transaction happening. Some of them will be within the same shard. Yeah.
So you said that that I can message people on the network on this website. So I tried to message you, the test user. For some reason it says the account doesn't exist.
Oh, it's because when we made test user, we weren't connected to the internet. So it was just a front end, like it didn't actually send that transaction. Remember I moved back that page?
You can try sending it to Samir and say MDR. He's looking for these tokens.
So my ID is Samir, SAMDER. I'll take it.
So we'll try hitting it with 500 transactions per second now and see what happens.
All right. So you're gonna do like 500 TPS.
So what's the number of the detected number? What's the number?
Yeah, it's stuck at like 143.
Okay.
So hopefully we don't get more rejected transactions. Is that going? Yeah, I think it went.
Yeah, it went through.
Okay.
Dang.
All right, so the processed transactions went up, and on that TPS went to like 371. So no, it didn't end up seeing more than 371 transactions per second.
And nothing was rejected.
2 questions.
Yeah.
First, what are the hardware requirements for each node? How light are they?
Okay, so the hardware requirement for a node is when we do this on AWS, we use T2 micros. So it's just like 1 gig of 1 processor, 1 gig of RAM. We're building Shardus so that you can use like off-the-shelf computers for doing your processing. Now, you might need lots of them if you really want to scale up, and really that is how things should be, right? Especially in public networks. where lots of different people are contributing like small nodes, and they're like unrelated parties, so you get a lot of decentralization. Adrian.
Would it be possible to run this on a system on a smart microwave?
So Adrian wants to know if he can run one of these nodes on a smart microwave?
Microwave.
Yeah.
Microwave. Well, it depends on what the end application requirements are, right? So, depending on what network you're trying to join with your node.
Yeah, I want to run a node in a smart microwave.
Oh, if you want to run a node in a smart node, yeah, you could probably run it. I mean, if it has, a decent amount of RAM and CPU, you probably could, right? Join the decentralized food network.
How big are these payloads? What is these payloads?
So these payloads are basically doing like a coin transfer. So it's transfer a coin from account A to account B, and when you submit a transaction, like you can chat between like Adrian and you do that. So you created a message payload in the network. So they're fairly simple payloads. But that's what Bitcoin is handling right now, right? Whenever people transfer coins to each other. Dan?
I've got a vCloud deployment. I have my own cloud company, and so I have a vCloud deployment. Have you guys thought about or going to, you're in AWS and there's people in Azure that have all their transactions and nodes. So if I want to have, because I do a lot of stuff, we're looking at oil and gas and stuff that we don't want Azure or AWS sniffing because we don't trust those guys. So we have our own network. Have you ever thought about making it to where you can automatically do these nodes with a deployment with the APIs that come with vCloud?
Yeah. So currently we haven't built out to other APIs other than Amazon, AWS, but that's definitely in our roadmap to be able to handle different, general cloud providers or vCloud, and even, maybe.
I'd be happy to have you, use us as beta or work with us. We're a VMware enterprise partner.
Oh, awesome! Yeah.
So we'd be happy to be able to.
Yeah, definitely.
Interface with you.
Absolutely. Yeah, we'll talk about that. And yeah, we want to handle, make it very easy for developers to be able to build and deploy to different cloud platforms.
VMware's got 90% of them virtualized. So if you're going to still stay on a private network, people want to have those private networks. If you have vCloud,
Absolutely.
Just to add to that, Dan, basically we have had looked at the APIs for different hypervisors, including VMware, Zen server, and then also VMware. As we move forward, more and more APIs are being exposed to be able to automatically spin up the VMs and stuff like that with the private clouds. So we certainly can do that. It's something very similar to what we did in AWS. With a small change, we can do this.
Yeah, because that's where I'd be able to, because the clients that I'm going to go to with this blockchain, they don't want to go out there because they just don't.
Yeah, absolutely, right. Yeah, but we can work with you to get APIs developed to be able to deploy in those kind of clouds. So, awesome.
Yeah, so it looks like the transactions have died down on the network. I think people are satisfied with curiosity about the chat app. So yeah, this was a demonstration of scaling, where we're able to add more transactions per second to the network. The capability of it goes up as we add more nodes.
Yeah, so, what's that again?
I was just wondering, what I noticed was the trajectory of transactions remained the same.
Right, yeah. So to expand the network, it didn't hit it slow. I don't know, you want to run one with let's keep pushing it until it starts rejecting.
All right, keep pushing until it breaks.
Yeah.
Here it goes.
Your goal is to crash.
Are you going to do 600?
Yeah, let's do 600 next. Double link. Do it for like
Like 5,000 per transaction.
All right, here goes.
All right, so he's hitting it with like 600 transactions per second. Now you start to see the nodes starting to process those. Now we're starting to see some of the transactions getting rejected. Still not too bad. So now our TPS numbers are going up to like close to 600 transactions per second. So that's well within the range.
All right, want to do again?
Well, it did start to reject some transactions, which means that the network is starting to hit its load limits.
Is there any rate limiting step related to like how much bandwidth I have? So if I'm just like a regular user at home and I have Spectrum at 40 megabits per second, like do I have to get a business account to be able to run?
No, so the rate limiting is actually the Shardus network saying that, hey, we've got so many transactions coming in right now that we might not be able to handle your transaction. And then it'll send you a message back saying we couldn't process your transaction. But it does that probabilistically, so it as it gets closer and closer to hitting its limit, more and more transactions are rejected. So that was a design decision in terms of, do we want our network to take all the transactions that come in and just put them into a big backlog and process them whenever? Or do we want to give people, a sense of liveliness in terms of, hey, if I send my transaction in, I know it'll get processed in 10 seconds, or I'll be told that I have to submit this transaction a little bit later. So that was a design decision, and we chose to go with, maintaining, a scenario where people are told that they would be, have to resubmit their transaction because the network is busy.
So it's dependent on the number of nodes. It's just the number of nodes that you have.
Yeah, and as you increase the number of nodes, then the network can take more transactions, and less transactions will be rejected. So,
Is it completely linear? So if my nodes are going 10,000, does the transactions really track it, or does it start to curve off?
I think it curves off a little bit, and that's due to, there is always this disk I/O, and there's network bandwidth and so forth, the communication I/O. And also it'll depend on the type of transactions you have, where like if your transaction is like, hey, send from this account to 10 other accounts, that kind of transaction could actually, slow down the network more than just a more simple transaction where you're only changing something in one account. So, I think you had a question?
Yes. So, as of now, are you basically doing an iterative empirical process to determine how many nodes need to be added in order to keep the number of rejected transactions small, or have you arrived at some kind of a formula or an equation which says that as long as we keep the number of nodes at this level, we are guaranteed to keep the number of transactions being rejected at or below a certain level? Where are you in that?
Yeah, so there's a feature in Shardus called auto scaling, where the network figures out, before it even hits its max capacity, it figures out that, hey, the transactions per second are starting to go up, and I need to let more nodes into the network. So in a real scenario, you would always have some nodes sitting out here waiting to join the network, and some of these nodes that have been in the network for a long time, the network will actually kick them out and let a new node in, so there's rotation going on. And so that allows for the network to scale to be able to handle that higher throughput of transactions. Now, that's something that we're tweaking right now to figure out like what that auto scaling parameters should be.
So those parameters, like to know when the network knows that it needs to start scaling up and when it goes down, they're configurable like from your application. And so what the actual load that you're going to see is really application dependent, because your application is going to have different types of like transactions that do different amounts of load based on what it is.
Okay.
And so those parameters are exposed to the app developer, so they can like tweak them so that the network scales according to what their app needs.
Okay. Now, just one more question. I mean, in the real world, I would assume there's a finite real cost that's associated with adding more nodes. So you probably have to have a balance as to when to add and when to.
Yeah, so like for a public network, that's where almost all of these decentralized networks have a coin associated with that network, so that nodes that join that network are incentivized to join it by receiving some coins, right? So that's how you compensate for those resources.
Yeah, so your application, you would implement like some kind of token to incentivize people to like run nodes for your application.
No, I mean, I see your point about these things being exposed to the app developer, but and Joe Blow, the app developer of the street, may not have the level of knowledge that you guys have. So I'm just wondering whether you provide any kind of guidance or any kind of limits on the ranges as to what works and what doesn't.
Yeah, absolutely. As we learn to tune these parameters, we're going to document that information as well.
Yeah.
And the developers would, especially if they need help, could be working with us or like a blockchain consulting company that helps them, deploy.
This is a question I've been asked.
Yeah.
It's a good question. So the complexity of taking the network, the Shardus network, how easy would you say would it be for an application developer, an average application developer, to build their application using Shardus? I think that's a question.
Oh yeah, definitely. I mean, Amir, are you set up to be able to like show like how people NPM install Shardus and launch a local network? Can you do that? If you, because I think the guys are kind of interested in seeing that. If you want to just.
So we have some documentation available. Like as you know, the code base is written in Node.js, and so we've tried to follow like Node.js best practices in the development process that people would use to build applications on Shardus. So we have some documentation over here. Let's see if I can pull it up.
So if you go to like shardus.com/docs, you can see the documentation that he's pulling up here.
And the main feature of this is the Shardus CLI tool. So if you have experience building things with Node, if you build like a React application or something like that, usually what you do is you pull this command line tool that helps you create projects with React. So we created something similar called Shardus CLI that helps you create projects with Shardus. What that basically lets you do is initialize a project that you can pull in templates of working projects that we have as examples on our GitLab page, and then set those up quickly, run a test network on your computer, see it working locally, just like how you would with React or something. And then you can make changes on those templates, just like how people would do with React.
Do it real quick.
Now, this is Kyle's computer, so I'm not too good with Mac.
You probably want to come up here and do a quick bring up a command line, and you probably already have Shardus installed.
Show like what we're trying to do.
So like if you were one of the guys in the hackathon, what are the steps that you would need to get your network CLI?
Oh, okay.
Yeah. So Kyle is gonna show you here. It's kind of hard to read here, but I think he's already got Shardus installed. So what would be the first thing that they do? Well, in the docs, why don't you show installing Shardus, because you already have Shardus installed.
Right.
Right. So once in this docs, right here where it says npm install Shardus, that's the first step you would do, and that would download the Shardus software and get it ready on your computer. And once you do that, now you have this Shardus command available to you, and now you can type something like Shardus init, and then give it your app name and a template repo, which is like an application that's already built, that you're going to start off as a template and then build your application from that. So I think Kyle already has it installed, so now if he goes to the CLI,
Can you do a command plus or something? It's hard to read from here.
yeah, it's is it possible to expand your thing? Oh, there you go, that's better. Yeah, so he's got it installed already, and if you just type Shardus, that shows you the commands that are available. Init is what helps you get your project started. Once you pulled in a project, you can create a network with it. And this is our GitLab repo. And from here, is this, yeah, this is all public stuff. So you can see the coin app template is something that we already have sitting out there. If you want to do a coin transfer application, you can just do Shardus init and then give the name and then use that coin app template. And then it'll, don't forget the name.
So can you guys process smart contracts to the VM running?
So Shardus is just building the core technology. We view smart contracts as a layer above that core technology. So somebody could take Shardus, add a VM to the nodes, and then have a smart contract language that those nodes process. So that itself is kind of like an application. So Shardus doesn't come with a smart contracting system, but you could use Shardus to build various different smart contract platforms with it.
So it's compiling right now. We just ran the npm command to create a new project. And so now it's pulling down Shardus, it's setting up the project scaffolding, everything that lets you develop pretty quickly and interactively. So it looks like it's done. CGs and Shardus.
So why don't you just run a local network here, and then start up a local network and show the monitor.
All right.
So
go to that. Yeah, local host.
Go to this.
Local host 2000.
Okay, so he just entered it. That's done. So can you show the command that you entered?
Yeah, it was
Where's the command? Did you get lost?
npm run start.
So he ran this command called npm run start. And what does that do?
Basically starts the app with one node.
Okay, so it started the application which he got from that template, but it starts only one node, and so there you see the node running right there. And now you can use your front-end client to interact with that node to get your application built. But now the next step would be you want to start a whole network of nodes. So can you try stopping that node? npm run stop and run clean, and so that stops that node. So then his command here is Shardus network create using default settings. And when he hits that, now you see about 10 nodes got started here, and each one is running on a different port. Okay, so he actually created a network and defined the nodes, and now you just type Shardus network start.
So it creates an instances folder for you, and you have to CD into that instances folder and then run the start, and it'll start all the nodes that you created.
And so those are the nodes getting started, and then if you go to your client, you can see those nodes coming up, and then you'll see that the nodes start joining the network and all talking to each other. And synchronizing.
About
So-
5 minutes.
Yeah.
If you're a developer, you can get started like building your application, like defining what kinds of transactions it's going to have, what your data model should be, all that kind of stuff. It's all exposed in this sample application.
So it's there. If you just go to the shardus.com/docs, you can try it out on your laptop today.
Yeah.
These guys can.
There's a hackathon going on right now where
Project on
students
it.
are using the Shardus, like these tools that we just demoed to build things. So we're looking forward to see what comes out of that.
Yeah, our docs actually kind of guide you through how to build a chat app, and that's we think that's an interesting application to do, and you can add like more features to it and so forth.
And then lots of tools that we built that we
Yeah, and so as more people build things with this, they can have their own repos available that other people can then use as a template to build off of that and so forth. So this is going to make like building your own networks like super simple.
For your chat app, you're just composing messages to payload. You don't have a communication layer or whispering.
So it's just, right now, it's just direct end-to-end communication. So you just, the sender ends up sending it to the receiver. There's no other layer in there. Yep.
You mentioned enterprise level applications, other than financial or coin transactions and identity tracking. What enterprise level applications are there? Like, for example?
Like IBM is actually focused a lot on trying to bring blockchain technology to enterprises, and they actually have like IBM.com/blockchain as a place where you can see like all the different types of industry applications they're working on. So like one is they have a thing called like Food Trust, where they're helping companies be able to track the whole supply chain. Any ingredient or a product that's used in the final product can be tracked back to where the original source was. There's other enterprise applications for, real estate. There's enterprise applications in government, voting, things like that. So there's a lot of different areas. But people are right now, a lot of these things are still in sort of like the prototyping stages and not like production deployments. But eventually we're going to get there. And you'll probably be using, in a few years, you'll probably be using a blockchain without even knowing that you're using a blockchain, because something that you're using uses a blockchain on the back end. So. Do you have any other questions?
No question. This could be considered a very naive question. When I first heard of blockchain, one of the big advantages that people said blockchain has, because it's a peer-to-peer network consisting of a large number of nodes, it would be very difficult for somebody to spoof it or to do any kind of fraud. But here you are talking about breaking down that in groups of smaller nodes. So what mechanisms do you have in place to avoid a single shard from being spoofed, from being or any kind of fraud taking place? Because now whoever's trying to do it has a much smaller number of nodes to deal with. So how do you counter that?
So good question. So he raises the question that when you have a network divided into smaller shards, what if somebody attacks just one shard and tries to overtake that shard? And the whole idea behind blockchain was that you would have a lot of nodes in your network, so that it made it very difficult to take over the network. That kind of issue or concern is really very applicable in public networks, right? And so, we don't really know yet, like, what is enough number of nodes to prevent somebody from taking over that smaller network. But then again, we do know that like having 10,000 nodes doing the same thing is an overkill on the amount of redundancy, right? So there's probably a sweet spot in between. Now, the way that Shardus is structured, if you try to take over one node, it is as difficult as trying to take over the whole network.
How so?
Because, so to take over a node, you have to set up your keys so that your node gets assigned to that shard that you're trying to take over. Now, Shardus doesn't let you select your own keys. I mean, you pick your private keys, but the node ID that you're assigned is not selected by you. It's assigned to you by the network. So although it's based off of your public key, it's combined with some random information that like no node in the network would ever know, including nodes that are trying to get into the network, they would never know. So your node is basically randomly put somewhere in the network. So it makes it a lot harder. So if you want to get a 51% of the nodes in one shard, it's as hard as getting 51% of that network because you can't control which shard your node is going to go into.
Where does the randomness come from?
So the randomness comes from the transactions and the flow and other activity that's happening in the network. No, it's not a centralized random source, but it's a deterministic random source in the sense that all the nodes can come to the same random number. But it's based on activity that's happening in the network.
And so I'm assuming that in Shardus there is no central authority of any kind that kind of takes care of or monitors the status of the individual shards and classify definition. They're all supposed to be on their own. There's no one overseeing authority that says, okay, these shards are okay. There might be something going on in these shards.
Right.
Is there any such authority?
So you're starting to mix Shardus, the technology, with the applications built with Shardus, right? So Shardus, the technology, doesn't impose any of those kind of limitations. But once you build an application with it, it's now up to you on how you want to structure that, what the policies are going to be.
So what you're saying is that Shardus, the technology, will not prevent me from doing that if I wanted to do something.
Right, exactly. Yeah. Yep. Amira, what's up?
How much Shardus tokens are there?
Oh, good question. She said, how many Shardus tokens are there? So currently, what I say was like 14 million in circulation. And by the time the project finishes, we could hit up to like 40 million. And were you trying to get 1 million or so for yourself? Okay.
Okay, yes.
All right. So we have somebody collecting Shardus tokens here.
What's her address?
Any other questions? So let me switch over to this thing. Yeah, I can go forward. So we went through that. So just in summary, we have a global server and an enterprise server. The global server does sharding. The enterprise server, all the nodes hold all the data. That's the key thing. So each of those are, at a point where we're starting to do like alpha and beta testing with them. We're looking to form, wrong button. Yeah, we're looking to form partnerships with consulting firms and end users as well that want to use the technology to build a particular application with it. And we're also interested in having more people join the team. We would definitely, as things get going with Shardus, there's going to be a need for more developers to help out. And you'll be receiving Shardus tokens, and those tokens will be tradable on Uniswap DEX, or you can always give them directly to your friends and families, OTC. And if you're here, you can go to this website, fill out some information, about yourself in terms of like your social handles and things, and earn some Shardus tokens for joining like our Twitter channel and things like that, so you can stay abreast of what's going on with Shardus and also earn some tokens. And if you have any other questions, my email address is omar@shardus.com, and our website is shardus.com, so please feel free to get in touch with us. Thank you very much for coming out.